Now in this section we will be focusing on the component of embedded system, that is a hardware component. So in previous section we have seen that the different components of embedded systems are hardware, software and real-time operating system. So this section focuses on the different type of hardware units, okay, hardware components in embedded systems. So basically embedded system components, they are divided into two parts, that is the hardware and the software, in which the sum of the important hardware components are given. Okay, so processor, power source, clocking, memory, timers, serial port, parallel ports are present, interrupt controller. So the block diagram of this we have seen in the previous section. Now in little brief we have to see about each of the hardware components which is present in the embedded system. So the first component, power supply. So we know that all these embedded hardware components, they require a power supply. So we can have either a battery operated or we can take the power from the mains. Okay, so battery operated, usually there will be portable system, and in the case you can also provide the power as such. The DC power supply can also be provided as such. So this circuit we are familiar, that is from the line we are converting the AC to DC. So with the help of a step down transformer and by using a bridge full wave rectifier, and here the capacitor, it is used for the filtering purpose to remove the ripple, and finally with the help of a 7805, that is a voltage regulator IC, we are getting a 5 volt DC output. Okay, so it can be given by using battery or using a circuit as shown here. So the power source, most of the embedded system, they have got a power supply of their own. Okay, and the supply voltage, it has got a specific operation range of voltages. So most of the embedded system, okay, they may be having either be battery operated or the power can be drawn from a line, and most commonly the voltage will be in these ranges. For example, if you are considering 8051, it will be operating with a DC voltage of 5 volt, and here the tolerance value is given as 5 volt plus or minus 0.25 volt, or it can operate at lower voltages also. For example, if you are considering the low voltage, that is 80 low voltage mode of operation, okay, so then it will be operating say in 3.3 volt plus or minus tolerance of 0.3 volt, or it can operate even with lesser voltages also. Even it can, for example, in the case of pencil cell etc., it can operate at this particular range. So if you are considering a remote control, okay, if you are considering a remote control operation, it may be using a pencil cell which is working with the DC voltage as 1.5 volt. Okay, so depending upon what DC voltage is required, okay, we may be employing this power source. And there are three possible methods of providing the power to an embedded system. Either it can have its own power supply, okay, each of the system it will be having its own power supply, or you can draw the power from a larger system, for example as in the case of a network interfacing card. Okay, so we can either draw the power from a larger system, or it can use a charge pump concept. Okay, for example, if you are considering the case of a ATM machine, as soon as we are inserting the ATM card, it will be getting what? Charged. Okay, so that is an example of a charge pump concept. Okay, or in the mouse or in the contactless smart card. So three possible methods of providing the power is being given here. Now the next important component, okay, that is after the power supply, the another important component, the basic unit of system is a clock. That is, we know that there are many operations which is being performed by a embedded system, and there needs to be some synchronization. So the most important thing is we have to control all these tasks. So synchronization is required, which is provided by the means of this clock oscillator circuits. Okay, and also it controls the time for executing an instruction. Okay, that is the control of CPU machine cycle. That is what we mean by this machine cycle, is that we have to go to fetch, okay, the data or the codes from the memory, and then we have to process it at the processor, we have to decode, and then we have to finally give back the result to the memory. Okay, so it controls, this clocking unit has to control all the CPU machine cycle and also for providing synchronization between several operations. Okay, that is the important component. Next we have the timers. We know the importance of time in embedded system. Okay, so for everything there will be a specified time given within which the system has to give the desired output. So we have to provide with timer circuits, and also timers and the real-time clock, they will also generate periodic interrupts. This may be required for the working of embedded system, and also say for periodic saving of time and date in a system. And microcontrollers, they are coming with inbuilt internal timer circuits for counting and timing devices. And also they may be having the real-time clock may also be used to obtain software control delays and timeouts. So there may be an interrupt, a sudden change which is occurring. If it is a real-time system, obviously embedded systems are real-time system. For example, in case of ATM machine or in the case of a air conditioning system, if suddenly an interrupt occurs, okay, it can be any type of hardware or software interrupt, the system has to function accordingly. For this, the providing of timers, that is a real-time clock, is very important. Okay, so generally when we are speaking about the interrupts, again we will see about the interrupt controllers, or commonly we refer to the hardware interrupts only. So timer, it is a device which count the input at regular interval using clock pulses at the input, and always we will be having the count which is being stored in a count registers. So the timer can also be used for generating of delay and for generating waveforms with specific delay. So in order to coordinate the functions of different functions which is being performed by embedded system, for synchronization we require clock oscillators and we require timers also to ensure proper functioning of a system. Okay, so this timer is also an important device. So we have seen about the clock oscillators and the timer circuits, and another component is about the interrupt controller. Although we are saying it separately, interrupt handler, that is also basically a timing device. Okay, so interrupt handler, it has to handle, okay, the interrupts. So simultaneously it is performing many tasks, but in between the something goes wrong or something needs immediate attention. Okay, that is what we mean by a interrupt. So it can be emitted by hardware or software. Usually when we say about interrupt, we commonly refer about the hardware interrupts. Software interrupts are also called as exceptions. Okay, so it will help the embedded system to respond to multiple real world events in rapid time. So usually there are multiple type of interrupt sources, but each of them will be given priority. So we will be learning in detail about the concept of interrupts, that is interrupt service routine, etc. in another module of this subject. Okay, for the time being we have to understand what are the components which is present in for the proper functioning of a embedded systems. Now in this slide you can go through the important points on the interrupts. We can read through all these points. Okay, so interrupt, we know it can be a hardware signal which indicate the occurrence of a event. So it can also occur through timers, serial communication, etc. It can arise, say, due to a division by zero result or an overflow during an ALU operation. There can be a software interrupt which may arise in an exceptional condition that may have developed while running a program. So all these are examples, simple examples of interrupts, and there may be many interrupts which is occurring, and there may be prioritization of this interrupt sources, and there is a service routine for dealing with all these interrupts. And certain interrupts are very important, they are not maskable, they cannot be disabled. And always a system, it has to give importance to this interrupt service routine to complete that particular task, and there is a programmable unit on chip for handling the interrupt mechanisms in a microcontroller. Okay, so it has to stop suddenly whatever operation it is being normally performing, it has to stop it and give importance to interrupt immediately. Okay, so it is expected to control the handling of interrupts and running of routines for interrupts in a particular application. So the operating system is designed in such a manner that it gives importance to the interrupts which is being occurring. So these are some of the points on interrupts. So next is a reset circuitry. Now basically what do you mean by reset? Okay, reset means that the processor is going to begin the processing of the instruction from a particular default starting address. Okay, it will be different for a processor, say on a power up. Okay, so on the reset of the processor, the processing of instruction again will start from a starting address. Okay, that is by the reset of the processor. Now this reset of the processor, it can be provided by an external RC circuit which is connecting to a reset pin of the processor. Okay, so how we are going to reset the processor? We are going to activate and deactivate our reset circuitry for a fixed period of time, thereby making the processor's reset pin active and deactive. Reset could also be activated by software reset instruction or by a programmed timer. This is a watchdog timer, again another timer circuitry which is going to reset the system after a predefined time interval. That is, after a few clock cycles, immediately the system is being reset. Why this is being done? Because if any fault occurs, it is going to rescue the system. Okay, so watchdog timer is very essential because it will automatically reset the system. So if any fault occurs in between and we are not aware, okay, the system is being immediately reset and the fault is being prevented. For example, consider the case of a air conditioning system. Okay, we want the air conditioning, say, to cool our room to a particular defined temperature. But in between, some fault is occurring. Okay, in sensor circuitry, some fault is occurring. But the controller, what will happen for the controller? It will be delivering a non-stop current. So reset has to occur. Okay. So whichever fault is occurring, say in the hardware component or something in the sensor circuitry, the system, if it is being reset, the controller could be aware. So in such conditions, etc., a watchdog timer becomes essential. Now next, the another part is the memory component. Basically, there are various forms of system memory. The two types of memory, basic two types of memory are read-only memory and random access memory. Now the read-only memory, that is a ROM memory, it can also be called as code memory. Why? Because the final program or the executable program which we are embedding, okay, that we are embedding into the ROM memory, that is called as the ROM image. Okay, so we are burning this program into the ROM memory which is called as a ROM image, and this read-only memory, it will be having, say, a size of, say, 4 KB to 64 KB, etc. We are storing there our permanent data. Okay, but in the case of random access memory, it is only a volatile memory. For temporary storage of data only, we are using the RAM memory. Say it will be of size only 250 or 512 bytes, etc. Okay, so these are the various forms of system memory. And we can say for volatile data, that is for RAM memory, whether it be internal or external, it will store only, say, variables. When the program is running, it can store the variables, or it can store temporary buffers in case of speech or image, etc. And in the case of ROM, it is going to store the permanent types of data. Okay, so for all the storing of application programs, etc., we use the ROM. And also we can employ, in certain cases we can use the cache memories, etc., for storing the copies of frequently or whichever instruction we are using, or in even for storing of temporary results during the processing, we can use cache, additional secondary memories, etc. Now again, various types of memory is given. That is, it can be, we can have either internal RAM or external RAM. Okay, whatever it may be. For example, in the case of microcontrollers, there will be inbuilt memories. Okay, but in the case of say microprocessors, etc., we have to interface all the components. Now, when we are speaking of the internal RAM, it can be as internal registers in a microcontroller. It will be always for a temporary data storage or stack memory areas. And for the external RAM, it can be for the temporary storage data and stack in the case for the microprocessors. Okay, then either internal ROM, it can have say a programmable ROM, as I told, for storing of application program. Then we can use also a memory card, memory stick for large storages of data such as audio, video, images. Then also we can have an external ROM, okay, where it is not that we can externally we can have the ROM for almost all of the embedded systems except in microcontroller based embedded system. And then we can have buffer memory, RAM, cache memories, etc. So again we will be having both the serial ports and parallel ports. The serial port is for serial communication. Okay, and in serial communication we will be transferring only one bit at a particular time. And the common serial protocols are there like UART, SPI, SCI, okay, I2C, etc. And in parallel communication, we can send multiple bits of data at once. That is a basic difference between serial port and parallel port. Now for the time being, just understand that for enabling the serial and parallel connection, we will be having both the serial ports and parallel ports, and by using certain set of protocols, this communication is going to work. Now in second module, we will be learning in detail about all these serial protocols. Okay, all these serial protocols and also about the parallel communication standards. Now understand that there are serial ports and parallel ports also in the hardware components. Next, we have to see at the section on the input and output. We know that obviously system has to get the input by various means and the output. In order to display the output, again it has to interface certain components. So some example of inputs are given here. For example, a system, it can get input from say keyboard, a touch screen, sensor, circuitry, etc. A controller, say it will be getting input from its sensors. A ports, a serial communication port or parallel communication board. So by means of certain protocol, it is also going to get certain inputs from a peripheral. Now again a network card, it could get the input from a communication system. Okay, so all by various means it will get this input and output it will be sending to the real world, maybe through a display system like that of LCD or a LED system, or output to a printer. Okay, printer is also always output device, or by means of a modem. Okay, so it may send its output to alarm, actuators, etc. So some examples here of the input and the output is given, and each and every the output port, it is identified by its memory address or port address, and it can actually do the write operations, etc. to the port address. So there will be always a input output port also which is being present. Okay, so this is also important hardware component. So these are again examples of the input and output types of devices, interfacings, etc. So we can have the output LCD display, LED interfacing ports, and also touch screen. We can have it as a input as well as an output device. For example, it can be used to enter a command, a chosen menu, or to give a reply, etc. Okay, so for example, if you are considering the case of a automatic chocolate vending machine, say it can display a welcome message. Okay, so it will be having a display message. Again, it should be having a user interfacing, that is to enter which candy we want. Okay, or it can display about the amount which is required for each type of candy, and also many types of input and output interfacing it has to require. Keyboard or keypad, it can be used again as a inputs. And also we may have the pulse dialer, modem, and transceiver circuits, that is for the user connectivity through the telephone line network. Okay, so we know that we have to perform the routing of the packets, etc. in case of a internet communication. Okay, so for this types of routing of a transmission of the communication, that is to a wireless system, or in the case of a network, So we require a transceiver circuit. Transceiver means that it can both transmit as well as receive the byte streams. Okay, so for all these effective communication, that is for the packet routing, etc., we require all these devices. That is, we require a modem, okay, and we require a pulse dialer, transceiver, etc. Now, next another component is a bus. So we might have heard of what is a bus. That is a system, it has to be connected to a number of other external devices or system. So we can define the bus as a common set of lines by which it is connecting the multiple devices. And it can be either a serial bus or a parallel bus. That is for a serial communication or for a parallel communication. For either of this, they need to be a defined protocol. That is, a protocol means that a defined set of rules which allow the two devices to communicate each other. Okay, so we have to study some of the bus protocols like USB, I2C, etc., CAN protocol, etc. in the second module. So now we have to understand that bus is also an essential component. That is, in order to interconnect to several other multiple devices, we require a bus. That is a common set of lines. And another component also which needs to be included, specifically if you are using an application specific processor like that of a DSP, etc., for performing many of the operations, we require some types of signal processing applications. So we may require DAC circuits, ADC circuits, etc. So ADC, this is analog to digital conversion. Their operation, they are always required, especially if you are say processing image, voice, etc. So all these are required, and also DAC unit also will be done with the help of a combination of a PWM unit in the microcontroller and with the help of a external integrator chip. So understand that there may be, for signal processing application, we require both these types of conversion circuits. Okay, in addition to the normal other already inbuilt components, we require these conversion essential components also for signal processing applications. Now the most important component of the embedded system, or we call it as a heart of the embedded system, that is the processor. Because all other components, if it is present also where the actual operation is being performed, okay, or the actual decoding is being performed, it is done at the processor. So we can say it is a heart of the embedded system. There can be different types of processors based on the application. Now out of all this, the most important or the common one, we can say the most commonly we use a microcontroller processor or even a microprocessor. Now we will be dealing with this particular, that is an embedded processor, as a separate section. For the time being, we have to understand that a processor is the most important hardware component. It can also be called as a heart of the embedded system, and depending on the type of application, we can have different types of processors, with microcontroller being the most common. So in this section, we have seen about the different types of hardware units in an embedded system.